So today we're going to talk about slope and the rate of change, and we're going to use this doing our Doodle Notes here. So for the Doodle Notes, you have to write what I write, but you're allowed to doodle inside of these kind of given areas. So for example, since you're going to need color today, I'm choosing red and blue, you could do the run and just, as you're taking the notes, kind of color in the R, the U, and the N in blue, and maybe we do the rise in red. And you're going to see why I chose those colors momentarily. But when we talk about slope, slope represents the rate of change. And we always want to write the rate of change as a fraction. So this is some of the required information you need to write down. Fraction in simplest form. Okay. So you can think of a slope kind of like a skier, right? Someone goes down the slopes, goes down a hill. Some slopes are steeper than others. They have a higher rate of change. Okay. Some slopes aren't that steep, right? There's not a lot of change in the hill that they're going down. Okay. That's in general what the rate of change is, what a slope is. And we can relate that to lines. Lines kind of look like hills. Like a skier going down this hill would go pretty fast, or this hill pretty fast. But this one, not so fast, because its rate of change isn't as high as, say, this one. And we can actually get the rate of change as a number if we have 2 points. Okay, so that's why you see these 2 dots here. Those represent the 2 points that we're going to be using, okay, to find the rate of change. Now, the rate of change, when we start talking about different forms of linear equations and functions, is going to be represented by the letter m. So the rate of change is a fraction. It's a ratio between the rise and the run of a line. So how much does it rise and how much does it run? Okay. For example, this line here, how much does it rise from this point to this point? Well, it goes 1, 2, 3. So it rises 3. And it goes towards the positive y values, so it's a positive 3. How much does it run? I'm going to do my runs in blue. Well, it runs 1, 2 in the positive x direction, so that's positive 2. So for this line, the rate of change, or the slope, can be represented by the fraction rise or run. Positive 3 over positive 2. Three over 2. And we want to leave it as a fraction. We don't want to put it as a decimal, because if I leave it as a fraction, I know 3 is the rise and 2 is the run. If it's a decimal, I don't really know what the 1, the point, and the 5 mean. Right? So I want to leave it as a fraction. On this one here, we can do the same thing. The rise is up 2 in the positive direction, so positive 2. And the run, 1, 2, 3, 4, is 4 in the positive direction. Now, slope, remember, is the rate, or the ratio between 2 and 4, rise and run. So this is 2/4. Now, it's got to be written in simplest form. So 2/4 is really 1/2. How much do you go from here to here? Are we rising, or are we really falling? Right, we're falling. So we're going to go actually down 1, 2, 3, 4, 5, 6. So the rise is negative 6 because we went in the negative direction towards the negative y values. The run is 1, 2, positive 2. So my slope for this line here as a fraction of the rise and the run is going to be negative 6 over positive 2. And negative 6 over positive 2 is negative 3. So my slope of this line is negative 3. Now there are other ways to find the slope if we're not given a graph. Say we're just given points, so we don't have any lines and we can't count. Now we could take these points and plot them and make a line, and then we can count. But let's say we don't have any graph paper. There is a formula called the slope formula that we can use. It's when you have 2 points, say an x1 and a y1, and an x2 and a y2, and so 2 x and y points. We can find the rise and the run between those by subtracting. So our slope formula is to take our second y value, y2, and subtract the first y value, y1. And these 1s and 2s are just little subscripts to show that this is the first y value, that's the second y value. The same thing for the x. So this is x2 minus x1. That shows the rise and the run without using the graph. Alright, so let's go over finding the slope, this problem you did on your own. So I have my slope formula. That's y2 minus y1 over x2 minus x1. And I use that formula when I don't have a graph, but I have points. So what I'm going to do is I'm going to do this problem right here. So I have the point 6, 0, and negative 8, negative 1. And I'm going to label those with the x1, y1, because that's my first xy coordinate, and x2, y2, because that's my second xy coordinate. And now all I have to do is plug those values into my slope formula. M equals y2 minus y1. So when I put that in, that's negative 1 y2 minus 0. And that's all over x2 minus x1. So that's negative 8 minus 6. And then I simplify. So remember, a slope is always a fraction in simplest form. Negative 1 minus 0 is negative 1. Negative 8 minus 6. Well, remember our integer rules. If I have negative 8 and negative 6, I have a negative 14 altogether. In our last integer rule, negative 1 divided by negative 14. Well, a negative divided by a negative is a positive. So our answer, the slope between 6, 0 and negative 8, negative 1, is 1/14. And generally I don't like to write my fractions like this. I prefer to write fractions like this. But in this case, it just wouldn't fit in the box that well, so I wrote it that way. So now I want to go over the slope of a horizontal and vertical line. So a horizontal line looks just like this. Okay. Now our slope is the ratio between the rise and the run. as we read it from left to right. So as we go from left to right, just like we read a book, does this line go up or down, right? Is it rising? Is it falling? No, it's going steady. If a skier was skiing on here, they wouldn't go up, they wouldn't go down, they would probably have to walk. So the slope of a horizontal line is 0. Now, the slope of a vertical line, that's an interesting one. So think of a vertical line as going up and down. Okay. And as we read this from left to right, well, it's kind of hard because the left we have nothing, and then we have a line, and then the right is nothing. So the rise here, right, as I kind of read this, if I'm on the line, the rise is infinite. It just keeps going and going. There's no number for that. Okay? The slope of a vertical line is going to be undefined because it's always rising and it's not running. So the slope of a vertical line is undefined. Okay, and the other really important aspect of counting slope when you have a graph like this is the way you count is going to tell you whether you have a positive value or a negative value. So here I went up towards the positives. Whenever you go up, okay, and whenever you go to the right as you're counting, those are always positive movements. If you count down like we did here, we went down 1, down 2, right, down 6 towards the negatives. If you go down, then it's going to be a negative movement. If you go left, which we really didn't have to do, but we could have, if we went left here, it'd be -4, -2. Okay. So if we went left, it is also a negative movement. We're going towards those negative values. Okay. And when we talk about these values here, 3/2, right? 1/2. This one's -3. Steeper slopes have a greater absolute value. That means no matter the sign, right? Kind of get rid of the sign, don't think about it. The absolute value is always that positive number, the positive part of the number. So 1/2, that's not as steep of a slope. If a skier is going down that, it's going to be fun, but what about this one? Right? This one is 3, well, -3. But that 3 is bigger than the 1/2, so it's going to be much steeper. And the skier is probably going to have a lot more fun going on this one, although to me it looks pretty dangerous. The last part we're going to go over for slope is how we can actually create a line if we have a point and we have the slope. So we're going to be asked to do that here. Plot a line that starts at the origin and has a slope of -3 and label it A. Well, the origin is right here, right, 0, 0. And we want it to have a slope of -3. So that's -3, and if we write slope as a fraction, that's -3 over 1. And remember that the slope is, sorry for the shadow, is rise over run. So as we go back to our problem here, we're going to rise -3, and we're going to run a +1. So let's count that. My rise is in red, so I'm rising -3, which means I'm going down. 1, 2, 3, -3. And I'm running 1, which means I'm going to the right. That's a +1. And there's my point. And to graph a line through those 2 points, I use a ruler. Make sure you show your arrows because this line's not going to stop. And there you are. This one is line A. Now I want you to pause the video and I want you to try to plot a line that starts at 0, 4 and has a slope of -3/4, and you can label it B. Okay, so what you should have is a dot, okay, a point at 0, 4. That's 0, 1, 2, 3, 4. And your slope is -3/4. So that's -3, 1, 2, 3, -3 again. Now, I've already used this negative symbol. I used it on the 3, so I wouldn't use it on the 4. Okay, I have -3/4. It's not -3/4. So since I've already gone down, I've gone in a negative direction, I need to go to the right 4. 1, 2, 3, 4, +4, and plot that point. And there's my new line. It's going to be line B. And make sure you have your arrows. If you went off the paper, you can always erase it. Mine kind of smudged a little bit. And there you have it. That's line A and line B. So now that we've filled out our slope page, we're going to cut out the margins, okay, and then cut out this work here because we do want to keep this. It's just not going to fit in our books. So we're going to cut this out. Okay, we're going to cut out these two problems here, and this is how they're going to look when you put them into your book. Okay. The entry is slope. I've cut out the margins and I've taped or glued this on the right side, and on the left I just have these two examples that go with this. If you want to, you can make a line so you know that this problem is over here, this problem is over here. Maybe you want to label this as number 1, label this as number 2, so you can see your example. Okay. And then of course yours might have some doodling that mine does not until now. Okay. On the left side of your book, I also want you to do these following problems. Find the slope between the given points 5, 3 and 3, 13, -2, -3, and 6, 3. You don't have to use color. I suggest it, but you don't have to. I do want you to use your slope formula and label x1, y1, x2, y2, x1, y1, x2, y2. When you're done, show your teacher, and then you can move on to the practice problems.